Hello and welcome back. We know that in machine learning there are two kinds of supervised learning problems: regression and classification. So far we have seen end-to-end process of executing a regression problem or solving a regression problem. In regression, the target variable will have continuous values. That means it can be between minus infinity to plus infinity. One of the examples we have taken was salary prediction, and there we had salaries between maybe 10,000 to maybe around 150,000, something like that. Now let us jump in and try to understand a classification problem and how to solve a classification problem. We call a problem a classification problem when the target variable has got countable number of values, discrete values, or when you take distinct values from the y variable or the target variable, if you can count them, then you call the problem as classification problem. In this particular example, the target variable has got triangle and circle. When you train a model, it will understand whether a record belongs to triangle or circle. When a new record is passed into the model, it will predict whether the record belongs to triangle class or circle class. So this is called as classification problem. To visually show a simple example here, I have taken x1 and x2, two input variables, and the shape of the object is circle or triangle. When you use an algorithm like logistic regression, it will try to do a line, a decision boundary we call it as, between these two classes. The data which is above the line belongs to one class and below the line belongs to another class. This is all layman's terminology. We'll see how mathematically it works in coming classes. But to simply understand, the machine learning actually tries to do a decision boundary between two class records. And when you use the algorithm and try to make prediction, it will give you either a value greater than something or less than something. That is called as threshold. We will understand all these things in detail in coming classes. But before we go there, let us try to take one problem and try to solve it. One classification problem and try to solve it. Suppose that you are trying to build a mobile application which actually tries to look at a handwritten digit. Human beings write numbers in different way. I may write 2 in a different way and you may write 2 in different way. So if a computer can understand a human written number, we can do many things with it. So suppose that you are building a mobile application which actually takes a picture of a handwritten digit and understands whether it is 5 or 6 or 2 or 0 or 1 or 9. So we have 10 classes there, right? From 0 to 9. When you take a picture, the mobile application should be classifying that picture as either 0 or 1 or 2 or till 9. So 10 classes are there. So to solve that problem, we have to collect the data. Quite often in data science and machine learning and AI projects, you need to prepare the dataset. To solve this particular problem, we need to prepare dataset. How will you prepare the dataset? You try to ask people to write numbers, individual 1 numbers, right? Maybe 1, 0, 4, 5 like that, and take a picture of it. The first step is to collect the data. Take a picture of it and then convert that picture into pixels. Here we are seeing 784 pixels from 0 to 783, and then flag it or label it, because as a human being, when you took the picture, that whether the written number is 1 or 2 or 5 or whatever, right? Even if the person writes in a different way, we can understand as human beings. So flag it. So this is called as data collection. And when you feed this data into machine learning algorithm, it will identify the pattern of the pictures written or the pixels inside the picture and the relationship between the pixels and the flag, and that is supervised learning. It always learns using the target variable. So if you have to prepare the data set, we need to do this. First step, take a picture, of handwritten digit, then convert it into pixels, and then flag it. How many number of pictures you can take and convert, that much the model will be accurate. How much data you pass, that much model will be accurate. But fortunately, we have this data set already prepared. We call this as MNIST data set, MNIST. If you type MNIST data set in Google, you will get it. In Kaggle and other places you will find this. So somebody took the pictures, converted each picture into 784 pixels and flagged it as either 0 or 1 or 4 or whatever. So we'll use that data set and try to build a model. When I said there are 10 classes from 0 to 9, it is called as multi-class classification. There are multiple classes. We will try to understand binary class classification first, and then we'll jump into multi-class classification. What is binary class classification? Either yes or no, 1 or 2, right? So there will be only 2 classes in your target variable, then you call that problem as binary class classification. If you have more than 2 classes like this in this particular data set, you call that as multi-class classification. So we actually made this multi-class classification problem to binary class classification by taking records belonging to 5 and records not belonging to 5. So that is our problem, and we are going to use that data set and try to build a model and solve the problem and understand the metrics and other things used in classification, because the metrics used in classification and regression are different. So let us meet in another session to build a model and understand all the other metrics and other stuff. Thank you.